Welcome to another video. This video is about finding the domain of the composition of functions. I did this video about 2 years ago. Unfortunately, there was a mistake. So I took down the video and I made it unlisted. But if you already have this video available to you, or you're playing the long playlist for algebra, you're going to find this video and then you find the mistake. And that's what happened. And I got a notification that there was a complaint about the video, and the complaint was valid because I already saw the mistake. I just didn't redo the video. Now I'm redoing the video and I'm going to explain what happens when you take the composition of two functions and you need to establish the domains. Let's get into it. First things first, you know that the domain of f is every value of x that you can use except when this is going to be equal to 1, because then this rational expression rational function becomes undefined. The same thing happens on this side, because if x is equal to -4, g is going to be undefined. So we're going to say in our minds right from the beginning that x cannot be 1 and x cannot be -4, but that's you just looking at it. When you do the composition, the things you can exclude will immediately change. So this is what happens. We're doing a composition of f over g, so it means f is going to be feeding on g, which means g becomes the input for f. If g becomes the input for f does not really need to worry about its own original meal. So that's how you should think about it. So f is going to be feeding on g, so your concern at that point is g and not whatever f was feeding on as the original function. So let's look at it. If we compose f of g, okay, of x, it's going to be whatever you were having here will no longer be x. So that excluding 1 that we talked about initially will just disappear because the input is no longer x. The input is now g of x. So what we're going to have will be f of the input. You see, this was f of x. Let me write it correctly. This is f of x and this was g of x. Okay? G of x. Okay, the new input is no longer x, it is now g of x. That's the meaning of composition. Let me say that again. Do not worry any longer about x, because the new input of f is not x, it is g of x. So as long as g of x is okay, f of g of x is going to be fine. You get that? Okay, so let's see. So what is f of g of x? So if g of x exists, then f of g of x is, let's just say the word okay, because we still have to consider the final picture to see if x comes back to become the the food. So here, what is f of g of x? What this means, which is the same thing as what we wrote here, okay? Remember, this is another way to write this. So this is the function. We're saying instead of putting x, we're going to be putting g of x. So this function will now look like this. Everywhere you see x here, this is what you're going to put. So it's going to be g of x plus 2 over g of x minus 1. But what is g of x from the original definition? The original definition says that this is equal to x plus 1 over x plus 4 plus 2 over x plus 1, x plus 4 minus 1. So this is a complex fraction. In order to make a complex fraction not as complex, what do? We multiply the top and bottom by that denominator that's causing trouble. So what we're going to do is we're going to multiply this by x plus 4. Multiply this by x plus 4. Okay, we're going to do the same thing. Multiply the top and bottom by x plus 4. Okay, let me just do it this way. So if I multiply, so get rid of this then. So if I multiply the top by x plus 4, this is going to get rid of this, but we're going to have 2 times x plus 4 here. So this is what we have. We're going to have x plus 1 will remain here. X plus 1 plus 2 times x plus 4 is going to become 2 times x plus 4. In the denominator, we're going to have, this will get rid of this. We're going to have x plus 1, and this is minus 1 times x plus 4. We have x plus 4. Okay, let's clean this up. This on top is going to be x plus 1 plus 2x. This is x plus 1 plus 2x plus 8 divided by x plus 1 minus x minus 4. So what do we have? On the bottom, on top, we're going to have 3x plus 9. This is 3x plus 9. And here we're going to have x minus x. That's minus 3. So the answer to this is what? Okay, let's factor out 3. So this is 3 times x plus 3 divided by negative 3. What do you think that is? This cancels this. We have negative. This is equal to negative x plus 3. That is f composed with g of x. Now look at this. This turns out to be beautiful because this is a linear equation. This is a polynomial. Every single value of x is going to work. So we don't have a problem with this composition. The only problem we had, like I told you, is that the food must exist. What was the food? It was g of x. Will g of x always exist? We'll come back here and go, well, g of x will only exist if we avoid this being equal to negative 4. So the domain of this is actually all of the values of x except negative 4. Do you see that? So as soon as you start, avoid focusing on this if that's going to be the one that's feeding on the other one. And after you've gotten your final answer, look for the domain of this function. If the domain is all of R or whatever it is, recognize the domain and then make sure you recognize the domain of the input to this composition. So we say that the domain of f composed with g is equal to all values of x is equal to the set of x such that x is not equal to negative 4. That's it. Every value of x, as far as x is not negative 4, is the domain. And you can write this using interval notation, or we can write it this way. It is equal to domain is negative infinity to negative 4 union negative 4 to infinity. So that's it. Never stop learning. Those who stop learning, stop living. Bye-bye.